Today we are going to begin our Introduction to Trigonometry, which is my very favorite math topic to teach, so I'm super excited to start this with you guys. We're still going to be working on our algebra skills also, but today is the day we're going to begin something new. So you guys had a very brief introduction to trigonometry when you took geometry, but it was just a little tiny snippet of geometry. And this year we're going to take that and we're going to really expand it into a lot of new and exciting areas. So today we're going to be talking about radians and degrees, probably not things that y'all have heard of before. So this unit, no matter what your previous skills were in algebra or geometry, this unit kind of puts us all on equal footing because all of y'all are going to have the same background knowledge on this, and so it's going to be brand new for everybody. So we're going to take it slow, go through it little by little, but I'm super excited to start this with you guys today. So you remember from what you have done in middle school, from what you've done in geometry, that you guys looked at measuring angles. And if we look at this particular angle here, I've got a protractor for us, and this would be called the initial side of the angle. It's the one that lays on the zero. This would be called the terminal side. The initial side is where it starts. The terminal side is where it stops. So if I look at how far it is from the initial side to the terminal side, and I read my protractor, I can see that this angle is 45 degrees. And degrees are the units that we put on our angles. So what we're going to learn today is a new way of measuring angles that does not use this degree symbol. That new way of measuring angles is called radians. Radians are great for calculus because radians are unitless. So you guys remember when you did area and when you did volume, you had to change your units because, like for area, 2 centimeters times 3 centimeters is 6 centimeters squared, and your units changed. Well, for calculus, it would be really helpful if we didn't have to worry about changing our units. And so that's why in calculus, most often, all your angles are measured in radians because radians are unitless, and so you don't have to worry about changing the unit depending on what you're doing. So a radian, what is a radian? A radian is the angle that is made when the radius of a circle, here's the radius right here, you guys remember that's from the center out to the side, the radius of the circle is wrapped around the side of the circle. So basically if you take this radius and wrap it over here, this length is called 1 radian, radius. So I have a graphic that I found that'll help demonstrate this. You can see I've got the radius right here. That blue line is the same length as that. And what they're going to do is they're going to take that radius and wrap it around the circle, and then that angle measure is 1 radian. Okay, let's look at that again. There's the radius, and they're going to wrap it around the circle, and that amount of degrees that they went through corresponds to 1 radian. So there's the radius kind of smashed up against the side of the circle. And so that is 1 radian in the circle. So the key to working with radians, watch this. If I take that 1 radian measurement and I let it go around the circle, do you guys see that it went 3 whole times and then a little bit more? Well, that little bit more turns out to be exactly the same amount as pi. Okay, remember your circumference for a circle. Circumference formula is 2 pi r. And see, here we went halfway around the circle. So instead of doing 2 pi r, we're only going to do 1 pi r because we only went halfway around the circle. And that distance right there is r, remember, because that's your radius. So pi times the radius, and in this case, r, radius, is radians, and so it's pi radians. Let's watch that again. So there's my 1 radian, and I'm going to go around the circle 3 and a little bit more. So halfway around the circle is going to be pi radians. Well, it turns out that is the key to converting from degrees to radians or from radians to degrees. You can go back and forth as long as you remember that 180 degrees is the same thing as pi radians. So to get from degrees, which has a unit, to get to radians, which doesn't have a unit, this is my conversion factor. 180 degrees is pi radians. And here I've got it for you right here. That 180 degrees halfway around the circle is the same thing as pi radians. Okay, so let's put that to use. So I have taken my protractor and I've just doubled it up, right? You can see now I have a whole circle, which is 360 degrees, And here's my angle. Here's the initial side of the angle right here. And here's the terminal side of the angle. So if I want to measure that angle, well, that's an obtuse angle, so I'm going to use this larger measurement right there, 170 degrees. So I tried to draw exactly around the protractor. Y'all forgive me for being a little bit squiggly with my mouse, but that radian measure that corresponds to 170 degrees, that's what we want to find. Well, we said that halfway around the circle, 180 degrees is pi. So basically we want to know what portion this is. So I am going to take 170 degrees and I'm going to multiply, my unit multiplier is going to be pi over 180. That's how I'm going to convert from degrees to radians. So I have degrees right here. I'll put it on there so you can see it. I have degrees right here. I have degrees right here. So degrees over degrees, those cancel out. And so what I'm left with is something that is unitless. Okay, so what will go into 170 and also 180? Okay, I can simplify that by dividing both of those by 10. 170 divided by 10 is 17. 180 divided by 10 is 18. And so my answer, 170 degrees, corresponds to 17 pi over 18 radians, and there's no units right there, right? Because my units canceled out, degrees and degrees divided away, and so I'm left with something that is unitless, 17 pi over 18. And if I type that into my calculator, 17 pi over 18, well, that works out to be 2.967 ... Goes on and on forever, right? Because pi is irrational. And that makes sense because all the way to 180 would have been pi, which is 3.1415, right? On and on forever. And so this is not quite that, 170 less than 180, 2.96. So most often you're going to see radians written like this with a pi and as a fraction, but not always. Sometimes you're going to see radians written like this. So how will you tell the difference? How will you know if I just put 15? How will you know if I mean 15 radians or if I mean 15 degrees? And the key is the units. If you see a degree symbol right here, I mean 15 degrees. If you don't see anything, then it's 15 radians, because remember, radians are unitless, so there will be nothing there. So this is 15 radians, but this is 15 degrees. Okay, let's go the other way. So let's figure out what angle measure in degrees corresponds to pi over 12 radians. Well, basically, I'm just going to go the opposite way. I'm going to take pi over 12, and I'm going to multiply by 180 over pi. That 180 has degrees on it, so now I'm going to end up with something that has units. That degrees must go on top. So if you're changing it into degrees, the 180 goes on top. If you're changing it into radians, the 180 degrees goes on the bottom so that it'll cancel. Okay, so let's see what happens here. Well, I can see that my pi's are going to cancel. They divide away. And then let's see how many times 12 will go into 180. Let's see what goes into both of those. Well, I can tell that 6 will go into both of those. 6 goes into 12 2 times. 6 goes into 180 30 times. Well, 2 and 30, I can simplify that again. 2 goes into 2 1 time. 2 goes into 30 15 times. So my answer to this is 15 degrees. I have the degrees symbol right here, so I need to bring that down. 15 degrees. So if I were going to put this on my protractor, let me turn on my arrow here. Put this on my protractor. Here is the initial side, right there at 0. And then the terminal side is at 15. So that angle measure of 15 degrees corresponds to pi over 12 radians. That distance right here is pi over 12 radians right there. Okay, let's just practice going back and forth a little bit. Okay, look at these. I have degrees, I have radians, and I want to convert it to degrees. So let's see how we're going to do that. If I want to convert to degrees, I'm starting off with 3. All right, I want my answer to have degrees in it. So that means I need the 180 degrees to be on the top of my fraction. All right, now this is one that wasn't a fraction. It didn't have pi in it, but that doesn't change what we do. We still convert it to degrees using this measurement. Okay, so I'm going to type this in my calculator. 3 times 180 is 540. Still got that degrees on there. And then I'm going to divide that by pi. 171.89 degrees is what that rounds to. All right, so there's my degree measurement that goes along with 3 radians. Okay, so remember, 3 is a little bit less than 3.14, right? It's a little bit less than pi. So it makes sense that my angle measure would be a little bit less than 180. So those correspond together. That makes sense. Okay, 2 pi over 5 radians. All right, so let's do this one. 2 pi over 5. I want to change it into degrees. So my degrees needs to be on top. Can't see my degree symbol there very well. There we go. Okay, let's see what we can simplify here. So now the pi's are going to cancel. And let's see how many times 5 goes into 180. 5 goes into 18 3 times. With 3 left over, 5 goes into 36 times. And now I've got 2 times 36. So 72 degrees is my final answer. Notice on both of these I had degrees, so that I have my final answer in degrees. Those units need to come down. All right, if I put that in my calculator, 2 pi divided by 5 is 1.256. Okay, 1.256, that's less than half of 3.14, so it makes sense that this would be less than half of 180. Half of 180 is 90, and this is less than half of 90. So that's a logical answer. And again, notice when I'm converting to degrees, I put degrees on both of them. Okay, let's go the other way. This time, let's convert into radians. Okay, so if I'm converting to radians, I want my answer to be unitless, which means that degree has to cancel out. So the 180 this time needs to be in the denominator so that it'll cancel out. All right, so let's see what I can do with this one. 240. Well, my degrees will cancel out. 240, 180. 10 goes into both of those. 10 goes into that 24 times. 10 goes into that 18 times. Okay, 6 will go into both of those. 6 goes into that 4 times. 6 goes into that 9 times. 4 and 9 don't simplify any further. So 4 pi over 9. So if I want an exact measure for radians, that's what I would get, 4 pi over 9. Now, sometimes in Delta Math, it's going to ask you to convert this to a decimal, and it will tell you specifically what to round to, either round to the tenths place or round to the hundredths place. So I'm going to type this in my calculator, 4 pi divided by 9. And if I round this to the tenths place, that's one number after the decimal, I'm going to get 1.4. If I round this, say, to the thousandths place, that's 3 numbers after the decimal, 1.396. So whatever it asks me for is where I'm going to round it. I'm just going to look on my calculator and see what to use. All right, notice on both of these, I do not have any units, right? I do not put a degree symbol when I use radians. In fact, I don't use any units at all. So 1.4, 1.396, whatever it asks me to round it to is what I want there. Okay, let's do 500. Well, so 500, that seems weird. Let me look back to my protractor here. 500 just means I went all the way around the circle, 360 degrees, and then I went 140 more degrees to get over here. So when I look at that radian measure, I'm going to go all the way around the circle. Well, if this is 1 pi, this is 1 pi, that's 2 pi, and then I'm going to come all the way over here. So my answer is going to be something bigger than 2 pi to get all the way over here. All right, let's see what I'm going to get. So 500 degrees. I'm changing it to radians. I want my degrees to cancel out. So I'm going to put the 180 in the denominator. My degrees are going to cancel. 10 divides into both of those. 2 divides into both of those. And that is as simplified as we can get it. 25 pi over 9. So that's the exact answer. And if I want to change it into a rounded answer, suppose Delta Math asked me to round to the tenths place, I'll type that in my calculator. If they ask me to round it to the hundredths place, that's 2 numbers after the decimal. But on neither one of those will I put a unit because radians are units.